class on the topic work, energy and power. Before we get into this topic of work, energy and power, one of the important prerequisites is we should be knowing the dot product or scalar product. So first let's hurriedly revise what is dot product. For details you can go to my lecture on vectors also and then come back to work, energy and power. Otherwise we directly right now hurriedly revise dot product and we continue with this chapter work, energy and power. The dot product of two vectors, that is A dot B, if they are these two vectors, this is magnitude of A, magnitude of B and cos of the smaller angle between the two vectors. So this is the dot product or scalar product. It is said scalar product because over here we are multiplying two vectors in such a way that the resultant quantity, it comes out to be scalar quantity. It has only magnitude, it doesn't have any direction. Now we have, as we have x-axis here, x dash, y dash. So we have unit vectors also. Unit vectors in this direction we say I cap. In this direction we call it as I cap, I caret or I hat. So obviously this way the unit vector is minus I cap, this way is j cap, this way is minus j cap, and out of the plane is the z-axis where we have k cap in this direction and inwards it is minus k cap. We have done it in vectors when we had done vectors. So the dot product of I dot I is, so over here I represents A and this I represents B. We can say it like this. So magnitude of A, magnitude of this is what? 1, it is unit vector, into magnitude of B, that is once again this unit vector, 1 into cos theta. I is this way, I is this way, so it is cos 0 is 1, so I dot I is 1. Similarly, j dot j is equal to 1 and k dot k is equal to 1. Now if we say I dot j cap, I is here, j is here, unit vector, magnitude of A dot B is magnitude of A into magnitude of B into cos theta, magnitude of A, I cap 1, magnitude of j cap, once again in unit vector 1, into cos of what? Cos is between I and j, x and y axis, I and j is 90 degree, cos 90 degree, cos 90 is 0, so this comes out to be 0. Similarly, I dot minus j, that will also be equal to 0. J dot I minus, j dot minus I, that will also be equal to 0. So either you say I dot j is equal to j dot I is equal to I dot k. Whenever they are two different vectors, then certainly I and j and k, etc. So this is going to be cos 90 and that is going to be equal to 0. This is one thing which we have to remember. Now let's say we have vector like, suppose 2i plus 3j plus k, this is a vector A, and vector B is, let's say, I plus 2j plus 5k, and we have to find A dot B. So we can also directly write it like over here, 2i plus 3j cap plus k cap dot I plus 2j plus 5k cap. Now we can make use of this thing what we have learned over here. So it is 2i dot I is going to be 2 into 1 into cos 0. So this we multiply with this. So it is 2i dot I, 2 comes over here. So 2 comes out, I dot I is 1. So over here 2i dot I is 2. 2i, when we multiply with j, it will come out to be 0. When I dot k will come out to be 0. So let's multiply I with I, j with j and k with k. 3j dot 2j is 6, k dot 5k is 5, so it is 13 units. This is scalar quantity, there will not be any I, j or k, they will not be there. Had it been a vector product, then obviously there will be I, j, k, that is unit vectors will be there, but over here this is only a scalar quantity, so we will get purely a number. We shall be using this thing when we are going to understand what is work.